Hey everybody, this lesson is going to get you ready for your upcoming IM1 quiz, Integrated Math 1 quiz on Module 19. So I have a practice quiz. I'm happy to email you. My email is, let's see, I'll type it down. So here we go. Whoa, 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 you don't need to see that big old font. How about this? Math at mrmathblog.com. Okay, that's how you can get a hold of me, okay? All right, and then I'm happy to email. Just tell me, what you want your Module 19 Integrated Math 1 quiz, okay? All right, we're on the coronavirus shutdown. It's kind of weird right now. So, all right, so we have this figure to the right. We're going to answer. So what kind of angles are 8 and blank are corresponding angles? Okay, so corresponding angles are angles that fall right on top of each other if we bring these lines together. So if I brought those lines together, 8 would fall right down on 6, okay? So 8 and 6 are called corresponding angles, okay? And then 4 and blank are vertical angles. So here's 4. Vertical angles are straight across, so it's also 6. So 4 and 6 are vertical angles, okay? And then 3 and blank are alternate interior. Okay, so here's 3 right here. Interior means these angles inside right here. Exterior would be these guys on the outside, okay? Interior is on the inside. So alternate means it's on one side and the other one's on the alternate side, okay? So 3 and 7. I know 3 and 6 are on alternate sides, but we already have a name for those. Those are called a linear pair. So 3 and 7 are the alternate interior angles, okay? And then what else do we have? We have 3 and blank are same-sided interior angles. So they're on the same side and they're inside. So these guys, 3 and 2, see how they're on the same side of this transversal right here and they're inside. So 3 and 2 are same-sided interior angles, okay? 1 and blank are alternate exterior angles. So exteriors are these guys and these guys. So here's 1. 1 and blank are alternate exteriors. Now it's not 8 because those are linear pairs. We already know that those are linear pair. So 1 and 5, okay, way over there, 1 and 5, okay. All right, now if 1 equals, whoops, I didn't mean to do that. Let me get this back in the picture. If let me get my pencil back up. If 1 equals 108, here's 1 right here. What's 5? Okay, well, if since these lines are parallel with these arrows right here, then these alternate exterior angles are congruent. So 5 is also 108 right there, okay? And then I think I did that right there, yeah. Okay, so now it says 4 equals 75. So I'll put a 75 right there. What's 6? These are vertical angles, so those guys are congruent to each other. Okay? All right, so here we're solving for x. And these parallel lines, you guys, that's telling me that these lines are parallel. These arrows right here tell me that these lines are parallel. These guys are called same-sided interior angles, and they're supplementary, which means they add up to 180. So if we add them up to 180 and combine 96 and 100 is 196, subtract 196 from both sides, and we get negative 16. Did I? Yeah, negative 16. Sorry, let's. So I'm thinking ahead here. Sorry about that. Let me paste that back right there. Okay. Anyways, and it can be negative, you guys. So it just means that the angle is 16 degrees less than this angle. It has to be 80. Okay, to be supplementary with the 100 up there. Sorry, you can't see what I'm doing right here. Oops, I didn't mean to do that. Let's go back and get my little sorry, I make mistakes all the time. Let me go grab this guy. This is what I want right here. Okay. These guys are same-sided interiors and they're supplementary. Okay, here's 9. Okay, these guys are called corresponding angles. And see how this angle would fall right on top of this one? And so corresponding angles are equal. So that means this guy equals that guy. So there we go. And then we'll subtract 11x from both sides, and now we'll add 9 to both sides and then divide by 3. Okay, 27 divided by 3 is 9. All right, so these guys are called a linear pair. Linear pairs are 180. They're supplementary. So if we just add them up, and we get negative 16 again, okay? All right, and then these guys here, these are vertical angles. Vertical angles are always congruent, so we set those equal. Subtract 12x, add 7, and then divide by 3, and we get 8. Okay, easy enough. These guys are alternate interior angles, and they're congruent, so we set those equal to each other. Subtract 5x, add 3, divide by 3, we get 6 on that guy, okay? All right, so here it says use the figure to answer each as true or false. So line L is the perpendicular bisector. Okay, so this perpendicular bisector right here, this line right here, says that this point is equidistant to the endpoints of the segment that it's bisecting, and it has to be perpendicular. You have to have that right angle. So I know that this segment equals this segment. I also know that this segment equals this segment. The theorem says if a point is on the perpendicular bisector of a segment, then it's equidistant to the endpoint. So it says AC is 3. Well, sure, it's the same as that, so that's a true right there. Okay, and then this guy says AD equals DB. Okay, this side equals this side. Well, that's true because it's a perpendicular bisector. That has to be the midpoint right there. Okay, and then let's see. So now it says AD, here's AD right here, is 1/2 the whole thing. Well, that's true because whatever this side is, this side's the same. Pretend like this is, I don't know, 7. Then this side would be 7. So 7 plus 7 would be 14. So AD would be 1/2 of 14. So that is totally true right there. Okay, and then this guy says that AD is twice AB. Well, remember, we pretended like that was 7, and that's 7. So it's the other way around. AB is twice AD, so AD is not twice AB. That guy's false right there, okay? All right, so here, use this figure to answer is true or false, and it says, notice that 1 plus 3 equals 180. Okay, well, I do know this, you guys, that 1 plus 3, or 1 and 3, are congruent to each other because they're vertical angles. And so if they're congruent to each other and they add up to 180 up here, then each one has to be 90, 90, because 90 plus 90 equals this 180. So that's a right angle, that's a right angle. That makes everything a right angle going all the way around right there. So that's true. So 2 equals 3. That's true. Where did I get 2 equals 3? Well, that's true because they make a bunch of right angles right there. So 2 plus 4. 2 plus 4, those are both right angles, so 90 plus 90 is 180. Okay, I know 1 is not less than 4 because they're all right angles right there. And then 1 plus 4 is not equal to 90, it's equal to 180, so that one's false also. All right, here we go. Let's keep going. Almost done. Okay, line A has this equation, 4x minus 3y equals 8. Now, most teachers will have you solve for y. And that's okay. You just got to watch out for that negative right there, and it trips up everybody. There's a better trick. If it's in the form of ax plus by equals c, here a is 4, b is this negative 3 right here, and c is 8. If it's in that form, then the slope is always opposite a over b. Okay, we talked about this before. The slope is always opposite this number over this number. So negative 4 over negative 3 is positive 4 over 3. So that's the slope of line A. Okay, if you solve for y correctly, you would get 4/3. But there's about 4 or 5 different areas you can drop negatives or forget how to divide with fractions. So what's the slope of a line that's parallel to line A? Well, parallel lines have the same slope, so parallel lines are also going to be 4/3. All right, we're going to use that information for this guy. So which of these equations is an equation that is parallel to line A? So we're looking for the one that has 4/3 on it. Okay, so what I'm going to do is just do opposite A over B. This one's going to be negative 3 over negative 4. Okay, negative 3 over negative 4. Oh golly, did I forget to do that? Negative 3 over negative 4. I did. This should be a negative 3, sorry. Sorry, -3. I make all kinds of mistakes, you guys, so I am human, just like your groovy math teacher is. I make mistakes all the time, just like your most awesome math teacher. So that would be a negative 3/4, not a positive 3/4. So let's put a negative right here. So this is -3/4, okay? Sorry, you can see that big red thing because, let's see, can I get that? Yeah. Here, this negative times a negative is a positive, but divided by another negative, there's 3 negatives, so the answer is going to be negative right there. Okay, so I'm going to have to copy and paste all of that. Dang, that just kind of sets up everything, so that's all right. So just remember that it's not that one because we got to match up it with 4/3. So I know it's not A, so let's keep going. This one's going to be -3/4. Okay, it's always opposite A over B. All right, when I do that, again, I apologize, I made a mistake. So -3/4 is going to get me, and I'm looking for 4/3. That's the slope. Parallel lines are 4/3. So which one of these lines are going to get me 4/3 right there? All right, so let's do the next one. So -4 over -3. Again, there's 3 negatives, so it stays negative. -4/3, almost. I want 4/3. Okay, this one's going to be it. So it's going to be -4/3, which is -4/3. That's our ticket right there. All right, so this next one says, what's the slope of a line that's perpendicular to A? Okay, so here's A, so A is 4/3 again. A perpendicular slopes are opposite reciprocals. So what I'm going to do is, since this slope is positive, I know a perpendicular slope is going to be negative, and we flip it, so it's going to be -3/4, okay? All right, so the last piece of this is which of these lines is an equation that has a perpendicular slope to line A. Okay, so I copied this with my mistake, and I know it's not this one. I'm looking for the one that has -3/4. Okay, the one with -3/4 is right here, so it's going to be choice B. They're the same equations as in number 23 right there. Okay, so I'm sorry, it's not that one. Shoot, not this one. It goes over here. Golly, lots of mistakes. So here's the answer over here. I've got to fix this so when I teach this to my class, I can act all super smart, because I'm not that smart, you guys. I know you guys think I'm super smart, but I'm just human, just like everybody else. Hey, good luck on your test, and let me know how you do. Take care.